The key is remembering that when you're multiplying numbers with the same base, you add their exponents. That's the thing we have to remember. Now, just before we go to this first example, like I was saying just a second ago we were going to do, I want to do this one bit here. Okay? Now, let's look at this one. I used 8 earlier. How about 8 to the 2/3? Okay, now this is a little different than what we've seen. But what we need to do is think of this as two separate exponents. Do you agree that we can write this number as 8 to the 1/3? 8 to the 1/3 squared? What do I do with exponents that are separated by parentheses? Tucker? Exponents that are separated by parentheses. I multiply them. So do you agree that 2 times 1/3 is equal to 2/3? So do you agree that these two things are equal to each other?
Yeah.
Okay. Now let's do this. Let's simplify one thing at a time. What is 8 to the 1/3? Well, that's the same thing as the cube root of 8. The cube root of 8 is equal to 2. And then I need to square it. So 8 to the 2/3 power is equal to 4. We okay there? Everybody happy with that? Is it annoying?
Yeah.
It's not annoying, it's awesome.
Seems kind of
Because what happened back before calculators and electricity, but after water and air, a guy by the name of John Napier came up with a way to calculate big multiplication problems by adding exponents called logarithms. Okay? And in the back of books, they would have these big tables, thanks Napier, that would give you, they were called log tables, and they would say that this number, 14, is equal to 10 to the, I don't know, 1 point something, 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 out 4 spaces. And 20 is equal to 10 to the 1 point something, something, something. Okay? So instead of multiplying 20 times 14, all you had to do was add their exponents. Right? Do you understand what I'm saying? It took multiplication and made it addition. If you could say this number is equal to 10 to this power, and this number is equal to 10 to this power, when I'm multiplying, all I have to do is add their powers. Adding was much easier than multiplying. Okay? It made the problem go that much faster for scientists and mathematicians.
Did they not know like traditional multiplication?
Of course they did, but it just saved a ton of time.
Okay.
Okay? And you'll deal with these in advanced algebra and graphing logarithms and all kinds of cool stuff. There are 2 types of logarithms. One is a base 10 logarithm, okay, which is what we had over here. And then there's also something called a natural logarithm, which uses the base of e. E is approximately 2.17182812828 something something, and goes on forever. It's irrational. Okay. All right. Done with that. Now that I've wasted 2 videos, not wasted, we learned something. Do you agree that there's a number 4n times 4n times 4n is equal to 4? That's what they started us with. Can I write this as 4 to the n plus n plus n is equal to 4 to the first? You agree with me on that? Do you agree that this is 4 to the 3n equals 4 to the first? N plus n is 3n.
So n would have to be 1/3.
So 3n is equal to 1, divide by 3, and n equals 1/3. Okay?